Welcome, welcome. We are continuing our study of topic 4, which is statistics and probability. You most likely just watched a video on mean, median, and mode. And in our notes packet, we looked at questions numbers 1 and 2. Today, we're going to look at 3 and 4 in this video. So, question number 3, our story says, James goes bird watching for 25 days. The number of birds he sees each day are listed below. Find the median, lower quartile, and upper quartile of the data set. Then they're going to have us find interquartile range, lower and upper boundaries for outliers, and identify if there are any outliers, and then draw a box plot of the data set. Okay, so what we are looking for here is whether or not you choose to use a calculator would probably depend on which test this is on. So I'm going to show this both ways. So the first thing is if you were doing this without a calculator, I doubt IB would give you so many pieces of data because it's time consuming. But the first thing we'd want to do in order to identify median is place that data in numerical order from least to greatest. So I've already gone ahead and done that. And we have 25 pieces of data. So if we take that 25 pieces of data and we divide that by 2, that gives me 12.5. So I'm going to round that up to 13. So you're going to have 12 on the front half, 12 on the back half, and you're going to have the 13th piece of data, which is going to be our median. So if you count that over, this is our median right here. Okay, so when it's time to find, so let me go ahead and identify that for part A. So median is 10. When it's time to find your lower quartile, the lower quartile is the median of your front half of data, and we exclude the median. So we have 12 pieces of data here. So I want to find the median of 12 pieces of data. Well, if you take 12 and divide it by 2, that splits our data up into 6 and 6. So 1, 2, 3, 4, 5, 6. So right in here is going to be quartile 1, and just double check 1, 2, 3, 4, 5, 6. So it's in between 8 and 8. So we know that quartile 1 is going to be 8. Now, if these numbers were not the same, you are averaging those two numbers together, or you can find the middle. And so that identifies quartile 1 as 8. And then we're going to go to the back half, and quartile 3 is the median of the upper half of data, excluding the median. This also has 12 pieces of data, so I'm going to split that up into 6 and 6. So 1, 2, 3, 4, 5, 6. So right in here is going to be my quartile 3. Double check. 1, 2, 3, 4, 5, 6. So my quartile 3 would be the average of these two numbers, which would be 13. So quartile 3 is 13. And basically, when you break your data up into a median and quartiles, it breaks all of your data up into quarters. So lowest 25%, highest 25%, etc. And for the next question, part B, it says find the interquartile range, which is the difference between quartile 3 and quartile 1. So for us, that is going to be 13 minus 8, which is 5. By the way, your formula packet does in fact have the interquartile range calculation on it if you forgot how to do that. All right, next question says find the lower and upper boundaries for your outliers. So I have on the green reference sheet that I have given you, there is some information about outliers. And so in order to find the upper outlier, there's a definition. The outliers are extraordinary data that are separated from the main body of your data, and they're either much larger or much smaller than most of the data. So to calculate the upper boundary of our outliers, we're going to take our upper quartile, which is quartile 1, it's another name for it, plus 1.5 times the interquartile range. Any values that fall beyond that upper boundary, above it, would be considered an outlier. The lower boundary is going to be calculated by taking the lower quartile, which is quartile 1, minus 1.5 times the interquartile range, and any values that fall smaller than that value are considered an outlier. And then when you're graphing them, outliers are marked with an asterisk on a box plot. So you can see there's an example down here. IB would be very specific if they wanted you to factor in sketching outliers with an asterisk. Okay, so what we're going to be looking for here is to find my upper boundary, and this is for part C. What we want to do is we want to take quartile 3, that's our upper quartile, plus 1.5 times the interquartile range. So quartile 3, we already found quartile 3, remember, was 13, plus 1.5 times my interquartile range, which is 5. So that's 13 plus 1.5 times 5, which gives us an upper boundary of 20.5. And then for our lower boundary, we're going to take the lower quartile, which is quartile 1, and subtract 1.5 times the interquartile range. So our lower quartile was the 8, minus 1.5 times our interquartile range, which was 5. And that gives us 0.5. So what that means is any piece of data that falls above 20.5 or below 0.5 is going to be considered an outlier. So if I look at my values, above 20.5 would be 22, below 0.5 would be nothing. So we do in fact have one outlier, and that outlier is 22, and that is the question for part D. And then the last question says, draw a box plot of the data set. Okay, so for our box plot, we know, I'm going to go ahead over here so I can use this space. We are going to start with a continuum. And I know I need my data to go out through 22. So I'm actually going to start at 0, and I'm just going to go by 5s. And I'm going to show you two versions of the box plot. I'm going to show you one where we don't even consider outliers, and then one where we consider outliers. So I'll start with the one where we don't have outliers. So my lowest value, 3, is going to be where the lower end of my whisker, or my box and whisker plot, sits. My highest value of 22 is where my upper end is going to sit. And I am going to have a box that is created from 8, from my median of 10, and from 13. So here's my 8, here's my median of 10, and here's my 13. And then I'm going to connect my box to those highest and lowest values, and that creates my box and whisker plot. What's the point of a box and whisker plot or a box plot? It is a visual representation of where your quarters of data fall. So 1/4 of your data falls in this little whisker, 1/4 falls within the lower box, 1/4 falls within this upper box, and another quarter falls within the upper whisker. 50% of your data falls in the box itself. So that would be like your middle 50% of data. Okay, if I were asked to create a box plot factoring in outliers, I only had the one outlier, which is 22, and we draw that with a little asterisk. So your next highest value would actually be 18. So your whisker would actually be drawn at 18. You'd still have the whisker at 3. You'd still have all of your other data values. So it just shows someone else visually what the box and whisker plot would look like if you didn't have that outlier, but there's my outlier. Okay, all right, that was question number 3. We're going to look at one more topic before we move on. Question number 4, for the following data, I'm so sorry, I wanted to show you how to do this on the calculator. All right, let's take a look at our data. Hopefully my calculator will hold up. I'm really low on battery here. So I'm going to go into my stat button, and I've already taken the liberty of putting all of my data in here. So 12, 5, 13, 16, 8, etc. And so one way you could find all of these pieces of data is you could just go in and calculate one variable statistics. So I'm going to hit my statistics button. I'm going to go over to calculate, and I'm going to choose option number one variable stats. And of course, I just forgot what list I'm using. So let's come back in here. We're using list 1, of course. All right, so I'm going to change this to list 1. I am not using a frequency list. I'm going to clear that out. And our median, lower quartile and upper quartile are located on here. You just have to hit your down arrow. So your minimum was 3. So that's the lower value of our box and whisker plot. Our quartile 1 is our 8. That's what we got. Our median was 10. Our upper quartile was 13. And our max was 22. If you wanted to sketch a box and whisker plot here, you could go hit your stat plot button. And I'm going to choose on. And if you scoot over, this is the one that factors in outliers. I'm going to go ahead to the one that doesn't factor in outliers, just to show an example of one. And I'm going to select my list 1 is where all of my X values are sitting. We didn't use a frequency list, so you can put a 1 here because that implies that every value in our list 1 exists only one time, which is correct. And I want to see the graph of this. So if you hit zoom 6, you're probably going to have some kind of other graph happening. Yeah, I do. I've got some stuff in here. So I'm going to clear this out. And I'm also going to go to zoom, and I'm going to choose number 9. And it will cater a customized window to your data. And there's my box and whisker plot. If you hit your trace key, I've got my minimum of 3, my lower quartile of 8, 10, 13, and 22. So there is an example of your box and whisker plot. If you wanted to see the other type of box and whisker plot, that's the one that shows you the outliers. If we go ahead and do that, same deal. We're going to go to the graph, and now you can see if you head out here, there's your max of 18. There's the outlier. It just shows up as a random point way outside. Okay, we've got one more question on this video. This is question number 4. So this has to do with the effects of changing data. So the question says, for the following data, 3, 4, 5, and 6, if each number is increased by 5, what impact will that have on the median, the mean, the standard deviation? So I do have on your green reference sheet what will happen when you change data, and I'll explain in a second. But anytime you add or subtract data, for example, if you subtracted 5 from every single piece of data, the mean, median, and mode are all going to be decreased by 5. If all of your pieces of data get smaller by 5, all of those values will get decreased by 5. The standard deviation and your variance, however, remain unchanged. So this question is asking what will happen to the median, the mean, and the standard deviation. So if I were to increase by 5, my median is also going to increase by 5. Of course, you could always find your data because you have your metrics, because you have the data itself, but there could be IB questions where they don't actually give you the data. They just ask you to describe the impact. Your mean, if all your pieces of data are increasing by 5, then the sum of all of your values increases by that same value of 5 for each piece of data. And then when you divide that by the number of pieces of data, it also increases by 5. And then for your standard deviation, we haven't really talked about standard deviation much, so I'm going to take a moment and explain this. So standard deviation, in IB, we use population standard deviation. And it's calculated by taking the square root of the sum of each of our X values minus our population mean squared all over the number of pieces of data. If you're working with a sample outside of IB, this would be X with a bar over it. This would be an N minus 1 down here. We're just going to look at population. And when you calculate standard deviation, it's really focusing on how far a piece of data is from the mean. So you want to see how much your data deviates from the mean and what your distribution of your data is like. So I want you to imagine that I increased all of my values by 5. So this x value would increase by 5, but the mean would also increase by 5. And so if both of these increase by 5, their difference doesn't increase at all, which is why there is no change on your standard deviation. And this question doesn't have anything about multiplying by values, but I did want to briefly go over what is on your reference sheet. So if they were to tell you, for example, that all of your data items were tripled, your mean, median, and mode would all get tripled, as would your standard deviation, but the variance would be increased by a factor of 3 squared. Okay, where does that come from? So if you, again, we're changing the little story here, and we're saying, what if instead of adding or subtracting, we were multiplying by something? In this calculation, if instead of adding 5 each time, we decided to multiply these by something. So I'm going to get rid of those plus 5s, and I would be multiplying every piece of data by 3. I would also have a mean that would multiply by 3. So it looks like there could be a change here when we calculate that standard deviation. However, since these both have a 3 on here, I could factor a 3 out. And that leaves me with a 3 squared. And if you have a 3 squared, that means this expression on the inside would get multiplied by 3 squared, which is 9. But when you take the square root of 9, you get 3. So the ultimate impact on the standard deviation would be that the standard deviation also would be tripled. But why is the variance not tripling? Well, variance is the expression inside your square root symbol. So variance is actually the sum of all of those values minus your mean squared divided by n without the square root. Or you could say it's your standard deviation squared. And if you remember it's your standard deviation squared, and we know that the standard deviation is tripling, then the variance must also be tripling. So it has an increased change by a factor of 3 squared. But if you look at this visually on here, if I had factored a 3 out of here, and that 3 was also getting squared, you can see now that we have a multiple of 9. So just something to keep in the back of your mind are the effects of constant changes on original data. Sometimes we also call that sensitivity of data. How sensitive is data to changes? This is also something that people tend to forget. We actually review this the day before you go in for your exam because it's just one of those topics that I'd rather you not have to sit there and recalculate everything. I'd rather you just know that adding and multiplying will have different effects on your data. All right, thank you so much for listening.